We'll be starting up here in a little over a minute. We'll give folks a chance to log in on a rainy day in New York. I don't think there's a song with that name. There should be. Okay, it's 9 o'clock, but we'll give folks another 30 seconds or so, and then we'll get started. Just want to make sure everybody gets a chance to log in. So good morning, and welcome to one of our foundational webinars. Today, we're going to be talking about asphalt pavement materials. My name is David Orr. I'm the director here with the New York State LTAP, the Corner Local Roads program. Just giving you an introduction, and we'll be watching in the background, the chat pod and stuff. Our speaker today is going to be John Rondinero. I'll tell you more about him in a second, but John, go to the next slide so we can finish up the logistics. So if you haven't been on one of these webinars before, down in the bottom of your screen, you'll see audio settings. If you have any concerns, put them in the Q&A. The chat pod, we ask you to open it. You won't be able to put things in the chat, but that's where we put in a link to the handout. There's a handout you might want to use. And we're going to be using polls, so a link to the polls will be provided as well there. So it's in the chat now. I'll post it again here in just a couple of minutes. And with that, I'm going to re-spotlight John, take myself off, make myself go mute, and we will go from there. Go for it, John.
Excellent. Thank you, David. Good morning, everyone. As David mentioned, my name is John Rondinero. I'll be your tour guide today for today's session. Just as a little bit of background, I'm a retired New York State DOTer for a couple of years now. Had a bunch of different roles in my career at DOT. I spent most of the 90s in our main office highway maintenance division in Albany, including a couple of years as the state's pavement maintenance program engineer. Then I finished out my time at DOT with 15 years as the department's director of materials engineering. Spent more than a little bit of time talking about asphalt pavement and materials. As David mentioned, topic of today's session is asphalt pavement and materials, and we really want to just focus on providing a high-level overview of the asphalt pavement's basics. David already touched on the using the Zoom. Just play around with the controls. We'll be asking you to use the raise hand occasionally. And any questions or comments, just pop them into the Q&A, and we'll try to answer them before we get done today. Want to mention that this session is a condensed session. It's based on the workbook that was developed for our full-day asphalt paving and principles workshop that we'll be holding in the spring, April and May of 2023. And we'll talk more about the workbook and the workshops in a little bit. Touched on Zoom, and just want to really mention real quickly the PDHs. This course is, or this webinar is eligible for one PDH in New York State for any of our PEs in attendance today. It is considered a course, but only the person registered can get the PDH. The way this is going to work, everybody that stays on for 75% of the webinar today gets a certificate of attendance. For the PEs that want the PDH, you have to stay on for 90%. But then if you do, once you get your certificate of attendance, you send it back into us. We forward it to one of the people on the local road staff that handles professional development, and they'll get you your PDH. For anybody from other states, thank you for joining us. Welcome. But you're going to have to check with your specific LTAP center regarding eligibility for the PDH. And as David mentioned, we're going to be using Pole EV. Already looks like people have tagged in. And first question was, who do you work for? Anybody else need to log in? But looks like we've got a nice wide range of agencies represented. Excellent. The Weekend, that's my answer. Very good. All right, now we'll hit the next poll. Want to find out who you're working for? What do you do? Okay, people are still tagging in. All right, looks like we got a lot of engineers in the audience today. Should be a good session, but nice wide range of that representation. All right, thank you. Move on to the next one. How long have you been at your job? Oh, real nice. Yeah, nice wide range of experiences. Got some relatively newer folks, and then we got some old timers like me. So nice wide range of experience and probably expertise. All right, last but not least, where are you located? You ping the map. All right, I don't see my favorite location yet. Got 3 favorite locations on this map. All right, we got there we go. Very good. Got nice wide range of representation from across the state. Got somebody out in the middle of Lake Ontario on a sailboat. Maybe that's in Canada. If we've got somebody joining us from Canada, that's awesome. Looking for somebody out in Long Island Sound and looking for somebody in the Atlantic. So nice wide range of geographic representation. Thank you. All right, so let's get right into it. As we said, asphalt pavement and materials, and the 4 key topics we're going to talk about today are pavement deterioration, repair options, hot mix and warm mix. In particular, we've got some specific changes that are going to come into play this year that are going to have a big impact on many of our local agencies. And finally, we're going to close out talking about good paving practices. So let's start out with a poll. What do you think is the most cost-effective way to keep your road system in good shape? Tag A or B. All right, that's what I like to see. We've got almost unanimous agreement. Applying pavement maintenance treatments on roads while they're still in good condition. Yeah, that's real key. Really, that's the key to success. You want to be focusing on those pavement maintenance treatments. All right, we call these why webinars, and we call them why webinars for a reason. We ask the question, no matter what the topic is, why do we do what we do? So in this case, we're talking about why roads and why pavement management. Well, roads, pretty simple. They're the backbone of the economy, and to keep the economy chugging, you've got to have a good road system. Pavement management is the framework that we use to keep that system in good shape, and it's focused on the key concepts of right treatment, right place, right time, and my own personal ad, right way. Within that pavement management framework, we focus on a pavement maintenance strategy, and we do that. That's where you're focusing on low-cost treatments to keep your good roads in good shape, and you do that because you're getting the best bang for the buck. But regardless of how good your maintenance strategy is, eventually all your pavements are going to wear out. They're just, nothing lasts forever. They're going to lose their structural integrity. They're going to lose their load carrying capacity, and you've got to do something in terms of pavement rehab to get them back into a like new condition. Here's a generic pavement deterioration curve. Up in the upper left, you're starting in an like new or as new condition, and over time, it's slowly going to deteriorate. You hit a certain critical point, and then that deterioration is going to greatly accelerate. Then as that pavement gets to the end of its service life, it levels off again. But in that point, your pavement's in pretty bad shape. It's essentially a gravel road. You can look at that pavement deterioration curve and overlay our treatment categories. Over the life of your pavement, you're going to be doing routine maintenance, things like your shoulder cutting, your mowing, drainage, ditch cutting, all those kind of things that you do on an annual or cyclical basis to keep that road, that road operating correctly. While the pavement's still in good shape, relatively new and in good shape, you're going to be performing your pavement maintenance or your preventive maintenance activities, and those are going to focus primarily on crack sealing, and applying thin wearing courses. Over the life of the pavement, especially in its early life, you're going to be performing corrective maintenance. No matter, again, how good your preventive maintenance activities are, some stuff's going to get away from you. You're going to have pavement that's going to deteriorate further, and you're going to have to do localized or area repairs, your pothole patching, things to get that pavement back in shape. But then at some point, that pavement is going to get into a little tougher condition, and you're going to be forced to do more extensive rehab and reconstruction. And why this is important, when you look at relative treatment costs, if you look at the bottom right-hand corner of the slide, when you're forced to do more extensive rehab or reconstruction, it's going to cost you 4 to 5 times as much, at least, as it would cost you to do maintenance strategy, preventive maintenance activities while that pavement's in good shape. And just a point here on the rehab and reconstruction costs, some recent research is saying that cost differential is 15 to 20 times as much rather than just 4 to 5, depending on the situation. Now, when we look at our repair options themselves, you can put them into 2 general categories. You've got your maintenance activities and you've got your rehab activities. And the big thing that differentiates them, with maintenance, you're not adding any structural strength. With the rehab activities, you are adding or restoring structural strength. And you see the different treatments under each category. We'll talk more about them in a minute. As part of your decision-making process, to pick which treatment is the most appropriate, you go through a pretty standardized approach. First step is you're going to be observing and inventorying your pavement distresses, and then you're going to be taking those distresses, rating them in terms of extent and severity, and then taking a deeper dive and looking at probable causes. In terms of the distresses themselves, you're looking at 4 major categories of distresses. You've got your cracking, so your typical longitudinal transverse cracking, your load-related, fatigue-related alligator cracking, edge cracking, reflective cracking, all those types of cracking that are going to be affecting your pavement. Once that cracking advances a little too far, you're going to be talking about disintegration of your pavement, and that's really where you developed potholes, and you're also counting in under disintegration wherever you've done any kind of temporary pothole repair. Another category are your surface defects. Those are things like raveling, polishing, flushing, those kind of things that affect the surface of the pavement. And then you're also looking at surface deformations, things like rutting, shoving, swelling, those kind of things that are showing you get movement in your pavement mat. And then again, you're rating in terms of extent and severity. It can be as simple as looking at extent and severity in terms of low, medium, and high. And then you're digging into your probable causes. And in terms of those probable causes, you are taking a deeper dive. You're looking at really what's causing that distress you're seeing on the surface. And some of those probable causes can include drainage problems, always a big problem with water, traffic loading, especially your heavy vehicle traffic, your heavy trucks, farm equipment, any kind of emergency equipment, and something that we don't usually think of, our plow fleets. They raise hell with our pavements. You've also got to look at your environmental or weather factors, especially the differentials between winter and summer. They put a lot of stress on our pavements. You've got to look at your underlying soils. They can be a big problem to deal with, underlying utilities and drainage structures. And then you've also got any kind of construction issues, design issues, or maintenance issues that may be causing problems with your pavement. So you've got a pretty straightforward treatment framework or selection framework that leads you to those treatments that might be the right choice to fix whatever issues you're dealing with. And you look at you take that inventory of distresses and the analysis of probable causes, and then that's going to lead you to a handful of different alternatives to consider. And we can deal with this on pavements we see every day. And in this case, here's a pavement that's in pretty rough shape, typical pavement we might be dealing with. You're evaluating your distresses in terms of extent and severity, looking at the underlying causes, and that's going to help you focus in on a variety of treatments, and then hopefully lead you to a recommended treatment or treatments. And you're going to be choosing from the pick list on the right-hand side of the slide. In this case, this pavement's in rough shape. You've got both the high level of extent or density of distress, both in terms of your cracking, especially your fatigue-related cracking, alligator cracking in your wheel paths. And it's that cracking is advanced to the point where you've got a lot of pavement deterioration. That piece of roadway is all potholed up. Underlying causes, you're going to have to look more closely at your drainage, what's going on in your ditches, what's going on with your underlying soils, what kind of loading are you dealing with in this kind of setting. You've probably got a lot of farm equipment that's raising hell with that road. And that's going to lead you to your selection of alternatives. In this case, you've always got a choice of doing nothing. And many times that's driven by the fact you just don't have enough money to do what you need to do. Drainage is always something you've got to look hard at. Then in terms of the pavement treatments themselves, in this case, crack treatment, the pavement's way too far gone. The same with patching, you'd have to patch the entire section of pavement. And a wearing course is not going to work here either. The pavement's just too far deteriorated. That wearing course is not going to last. And you can even say that probably applies to an overlay. You're just not going to get the expected service life out of an overlay. So you're really focusing on in this case, focusing on recycling, mill and fill or reclamation, and that's where your additional pavement evaluation is going to come into play. And we'll talk a little bit more about all of this as we go further on today. So while you'd want all your pavements to look like this, that'd be the dream. Many more of our pavements look like this, or like this, or like this. And if you got a pavement that looks like this, it's going to need a lot of work. And so that's a nice segue into our deeper dive into our repair options. We'll touch briefly on all of them. Again, we're looking at everything from overlays, mill and fill, recycling, reclamation, stabilization, all the way to total reconstruction. And we're going to cover these in much more detail in our asphalt paving workshops in the spring of 2023. We've got the schedule on the website. We've got a map showing all the workshop locations at the end of this slideshow. Love to see you there in the spring. Just starting off with our traditional overlay. One thing to remember here, anything less than an inch is considered a thin wearing course. It's a maintenance treatment, and it's not providing any kind of structural, you're not adding or restoring any kind of structural strength to the pavement section. The point with that less than an inch, that wearing course, is it's going to be, it's like painting the house. You're doing it to keep the water out of the pavement section. Anything over an inch and a half is generally assumed to add strength, and then it's a gray area between an inch and a half. One thing you always got to take into account when you're thinking about your overlays, you've got to be considering your curb reveals. You've got to be thinking about your guide rail heights or in any other appurtenances. You've got to be thinking about your underground utilities and drainage structures, and you've got to be thinking about any of your overpass clearances. In terms of heater scarification, that's one of the tools in the recycling toolbox. And in this case, you've got a oversized heating panel. In this case, being fed by a giant propane. It's a giant propane torch essentially. It's heating up the top inch to 2 inches of that pavement to about 300 degrees, melting it down, and then you're running through with a set of rakes or scarifiers, turns that material over, and it gives you a nice and you will be adding some rejuvenators most of the time. That's going to give you a nice new base for any overlay. In terms of cold milling, very standard operation that we're all familiar with. You're grinding up that pavement. You're typically conveying it into a haul vehicle. It's being hauled off site to an asphalt plant. It's either being used as RAP, recycled asphalt product in asphalt production. It can also be used in a pug mill to create a cold mix. And then sometimes if you've got an excess of cold milling or millings, you can be using it as shoulder backup. Cold in place recycling is one of the more popular treatments we use in New York State. In this case, we're looking at a single unit train, and that's referring to the milling machine that's in the middle of the slide. You're adding in some additional liquid asphalt. It's being mixed with the millings, and then you're laying it down in a windrow for the paver to lay the mat. Cold in place recycling, this is the more common train that we would see in New York. It's a multi-unit train. In this case, you've got a couple crushers in the middle. They're going to give you a more fine-tuned aggregate gradation, and that's going to allow you to be using a lot more fine-tuned mix design. Reclamation and stabilization, that's getting you down a little deeper. Whereas with the cold in place recycling, you're getting down 4 to 6 inches. With the reclamation and stabilization, that's going to allow you to get down 12 inches, maybe up to 18 inches. And in this case, you're grinding up both your distressed pavement and your underlying granular material, and it's giving you a nice deep recycled layer. A lot of times you're adding in a stabilizer, and that is creating a new base layer, and it allows you to address both your surface and your base distresses. It's a real nice treatment to have in the toolbox. For any of our rehab treatments, though, one of the key to successes is to do some additional pavement evaluation. You really got to find out not just what's going on at the surface, but what's going on within the pavement section underneath the surface of that pavement. And in terms of the go-to evaluation technique, pavement coring, it's money well spent, because you'd like to have your cores look like this, but typically they're going to end up looking like this. And in this case, you can see on the left, you've got a section that's debonded, and then also on the far right, and then next core in on the right, you've got some bottom-up cracking. So you'd never detect those from your surface evaluation or your visual evaluation. You really need to do coring to understand what's going on underneath that surface of that pavement. If you want to get a little more sophisticated, you can employ the use of a falling weight deflectometer, an FWD. Cornell, by the way, is a leader in terms of the use of FWDs, and they do a lot of calibration of the equipment in the state. What you're doing with an FWD, you're thumping your pavement, and from the data that you're collecting from that thumping activity, it's going to allow you to analyze the current structural strength of the pavement section, which is going to give you a good input into designing the new pavement section. And then last but not least, I think we might recognize the gentleman in this slide. This is the tried and true method. You really, test pit is going to allow you to get down deep, get down in there and really see what's going on in the underlying granular layers of the pavement. In this case, our director, David Orr, recognizing him. This is when he was a younger lad, but he looks like he's really enjoying himself, getting right down and dirty in that test pit.
But my hair wasn't gray then.
Yeah, no, you're a good-looking dude, man. You're young and all full of piss and vinegar. Real quick quiz, see if we've learned anything so far. What's the best technique in this situation? Best treatment? Just click on the item, and it should log your results. And David, are you seeing the results on your computer? I'm not seeing the results. Amanda and I thought we would be able to see them right on the screen, but I'll guess anyways. I'm going to guess that most folks looked at this and run it through our framework pretty quick. They've identified our distresses and rated it in terms of extent and severity. And in this case, the pavement's in rough shape. You got an awful lot of cracking and an awful lot of
Let's do this, John.
Yep.
Let's do this real quick. Folks, in your Q&A, throw in the letter you think, A, B, C, or D. Throw it in the Q&A real quick.
Good.
Let's see where we get there.
Yep. So in terms of the process itself, then you've got to look a little harder at your underlying causes of the distress. And in this case, you look at the right-hand part of the slide, it looks like you've got some water problems. Pavement's is not showing a lot of shape issues, so your underlying foundation's okay. So David, what are people saying?
We've got everyone. I'm getting at least one vote. Most of them are B and C.
Okay.
I got a few Ds and a couple of A's.
Okay, gotcha. Well, I'm going to agree with the B and Cs. What do you think, David?
I want to do some coring or test pits to know for sure.
Exactly.
What's underneath, because it's also possible it needs reclamation, and I'd certainly look at the drainage too.
Yep, absolutely. And so to David's point, if with that further evaluation, taking a good look at your cores and maybe a test pit, if you've got foundation problems, reclamation is probably going to be the answer. But if you don't have the underlying foundation issues, mill and fill and or recycling probably would be good choices. In this case, I can see why you'd say an overlay, but I think the pavement's a little too far gone. You're not going to get the service life out of that overlay with the pavement in that shape. But good, thank you. And David, that's the right way to do these from now on. All right, that's a good segue. Let's talk about our asphalt paving materials a little bit more. In terms of our paving materials, we've got hot mix, HMA, we've got warm mix, WMA, and we've got cold mix. We're going to focus on hot mix and warm mix today because there's some big changes coming in 2023. Cold mix is something that we use a lot of on the local agency side. It's a go-to treatment material. We cover that we're not going to cover it today, but we do cover it in significant detail at the workshops in the spring. And we strongly encourage you to join us. If you do want some further information about cold mix, both the production and placement, the workshop manual is a great reference guide. And then if you have any other questions, just shoot them to us at Cornell and we'll get you an answer. But focusing on hot mix and warm mix today. Hot mix, this is what you traditionally see when you're loading out your truck. There's a lot of steam coming off the top of that pile. But when you compare hot mix to warm mix, again, you're getting a lot of steam off the hot mix and you're getting almost nothing coming off the warm mix as it's being loaded out. And that's because of the temperature differentials. You can also look at the temperature differentials in terms of your paving itself, your laydown. And just I want to take a quick second to credit our colleagues both at New York Construction Materials and at New York DOT, the Materials Bureau in Albany. They're the tip of the spear in terms of advancing warm mix as a technology. And they're the reason we've got a lot of these changes coming in 2023. And they provided a lot of the information and pictures we're using today. So again, this is just a comparison during the laydown process. And as you can see, a lot of steam coming off that mat at 320 and nothing coming off that mat at 245. So what is warm mix? I think everybody in the audience today knows what it is. It's a variety of technologies that we're using to produce or place asphalt mix at a reduced temperature. And we're typically talking 275 or lower. And just as a reference, our hot mix is being produced anywhere from 325 to 350. And just a key point to remember, your temperature reduction really is going to depend on the technology and the situation. You can also look at the hot mix versus warm mix in terms of the amount of energy you're consuming. And again, you've got the temperature ranges on the x-axis and your fuel consumption on the right axis. It's telling you you're using a lot less energy when you're producing warm mix. You can also look at it in terms your warm mix technologies in terms of its workability. And the key benefit is that you've got a much more workable mix over a wider range of lower temperatures. So the blue line here is your traditional hot mix. Your green line is your warm mix. Your measure of workability is viscosity. So the higher the viscosity, the less workable, or the lower the viscosity, the more workable. And you can see that with your warm mix, that green line, you've got a much lower viscosity, meaning a much higher workability over a much wider range, giving you just a lot better product to be working with. So overall benefits of warm mix: lower fumes and emissions, lower energy consumption, and here's a key: better worker environment or conditions. Really important reason for looking hard at warm mix. You've got lower plant wear, so it's really reducing the cost of the asphalt producers. You've got decreased binder aging, which means your pavements should be lasting longer. You've got early site opening because you're working with lower temperatures. You're going to get to that lower temperature where you can get traffic on it sooner. You've got the opportunity for cooler weather paving. A lot of states are investigating this or looking at that real close. And then finally, for any kind of stiffer mixes that are being used, you can even use, or you do use that WA technology just strictly as a compaction aid. And warm mix is not anything new to folks at Cornell or folks on the local agency side. In 2013, we did a warm mix demo at the highway school. And David, correct me if I'm wrong, that pavement section performed real well and only was recently replaced, correct?
No, it's actually still there.
Oh, great, and it's still in good
got-
shape.
It's got two reflective cracks that came through that we thought might come through. They weren't crack sealed ahead of time. But it's holding up just fine near the tennis courts when you're out there next year at the highway school.
Gotcha. Oh, that's right. So it's scheduled to be removed. Gotcha. Well, thank you. In terms of our warm mix technologies, 3 general categories. You've got chemical additives, organic additives, which are waxes, and then you've got foaming process where you're injecting water into the system, and you've got 3 different ways you can do that. You can inject the additive directly into the PG binder, or you can use an aggregate carrier or a zeolite carrier to get water into the mix to allow it to foam. So we'll talk about each of these briefly. Here's an example of a chemical additive. It's the Ingevity Evotherm product, and that chemical is injected either at the asphalt terminal or the asphalt plant. In terms of your organic additives, a good example is the Sasabit wax, and those wax pellets again can be introduced either at the asphalt terminal or the asphalt plant. In terms of foaming techniques, first we'll look at the direct foaming technology, and a good example of that is the Aztec double barrel green technology, and it's a water injection system that sprays the water into the system and allows that asphalt to foam. In terms of aggregate carriers, the good example is the McConaughey LEA process, low emission asphalt. And it's a 2-part process. You're providing an additive that's being piped into the PG binder. You're then taking that modified PG binder and coating your coarse aggregate portion of the mix. And then you're introducing a wet sand into that mix, and that's going to foam up the asphalt and allow it to be produced at the lower temperature. And then finally, there's the zeolite carrier process. Good example is the PQ Advera technology. In this case, they're using what is called a zeolite crystal. It's a crystal that's got a lot of void space in it, and that void space fills up with water molecules. You introduce that crystal into the mix, and that water is immediately released, foams the asphalt, and allows you to produce at lower temperatures. So, why are we here today, and where are we today? Well, in September of 2021, DOT issued their engineering bulletin, EB 21047, and that moved the state to use of 100% warm mix asphalt. Did it by revising the 404 items, which were previously the warm mix asphalt items, renamed them as asphalt pavement, and eliminated the 402 items, which were the hot mix asphalt items. And the key here is, with those 404 items, you're looking at no more than 295 max Fahrenheit at the paver. So you're working at much reduced temperatures. And then overall, now, up till this point, DOT's been 100% polymer modified asphalt. So now it's going to be 100% polymer modified and 100% warm mix asphalt as of 2023. Bottom line, warm mix is the same as hot mix, just operating at lower temperatures. There's a very good chance that anybody on the local side is going to see warm mix in the coming season. A lot of the producers are moving over to warm mix. You need to closely coordinate with the producers regarding any kind of paving that you're taking on. And that's especially important regarding your rolling temperatures because, again, per the DOT spec, you're looking at 295 Fahrenheit max at the paver, but you also need to be completing all your breakdown rolling before the mat reaches 230. So 2 important temperature limits you need to be keeping track of. In terms of our overlays themselves, we'll switch gears a little bit and talk about our good paving practices. And we will focus on overlays specifically. One of the best places to start, the instructor for the asphalt paving and the preventive maintenance workshops, Gary Nelson, produced a 24-minute video, real nice reference guide, and really gives you a good insights from a practitioner's perspective. And Gary knows what he's talking about. 40+ years in the business. He was a heck of a pavement guru and a great guy to know and a great guy to work with. He did a real nice job with this. It gives you a lot of good insights into good paving practices. And even though it was referenced around hot mix asphalt, same good practices or best practices apply to warm mix. You just need to be adjusting for temperature differences. And one of the starting points that Gary worked with was, is the foundation ready? And if your pavement looks like this, I'd say your foundation is not good to go yet. First thing you want to be looking at it regarding the surface, you want any cracking you have, you want limited cracking for your overlays. So if you're looking at that left-hand slide, that pavement is too far gone for an overlay. You're really going to need to look at a more extensive treatment. In terms of the middle slide, you've got to get those cracks treated, got to get them sealed before you do your overlay, and preferably you do that the season before. And then in terms of the right-hand slide, if this is just a localized area distress, you can do an area repair or a local repair. But if it's more extensive throughout the pavement section, you're really going to be needing to look at a more extensive treatment. You're also going to look specifically at your cracks, and in terms of the left-hand slide, when you see a pond of asphalt like that, even not thinking about your overlay, that's a nightmare. That's an accident waiting to happen. And anybody on two wheels, anybody that rides a motorcycle hates to see that. You hit that with a drop of moisture and that turns into a skating rink. And then taking accidents off the table, you hit that with your overlay material, and that's going to make a big gooey mess, and it's going to raise hell with your overlay. In terms of the repairs themselves, you want to make sure when you're making those repairs that you've done a good job in cleaning and drying your cracks to be sealed. In this case, you're seeing that newly placed crack sealer material being pulled right out because it wasn't clean and dry. And again, that's going to raise hell with your asphalt overlay. In terms of pavement readiness, you're also going to look at your rutting. From the looks of the left-hand slide, you're probably dealing with shallow surface rutting in this case. You could probably get away with treating that with a shim or T&L, but if you're dealing with a pavement that looks like what you got on the right-hand slide, you've got to do something to fix that foundation before you do anything else. Because if you put an overlay on top of that, it's just going to end up looking the same in no time. And then last but not least, you got to be considering your potholes. And in this case, I was out there doing a pavement evaluation recently and got in over my head. I hear you all laughing at this point. And I also hear Tom Kane saying, stick with your day job. Comedy is not your friend. All right. In terms of our asphalt overlay mixed constituents, we're looking at aggregates and liquid asphalt, pretty straightforward. So let's take a quick quiz. What percentage of liquid asphalt is typically found in our asphalt mixes? So again, why don't you just put your answers in the Q&A and David will report them out. So what do we see, David?
John, while they're putting their answers in, had a question in the Q&A.
Yep.
Do towns have to use warm mix asphalt?
I'm sorry, say that again?
Do the towns have to use warm mix asphalt?
Well, if you're using a DOT spec, yes, you're going to be required to use warm mix. You're going to have to talk to your producers, because if you're using a different kind of spec or a different contract mechanism that doesn't require warm mix, you might be able to get hot mix. But the question is going to be whether the producers that you typically work with, are they going to be producing anything but warm mix? And this is it's a question mark right now. There's not a good answer, and it's really going to require the town, any of the localities to be talking to their typical producers. Do you have anything else you want to add to that, David?
I think the main thing there is that you got to have a spec, and the concern I would have if you're trying to do quality assurance, quality control on your own, are you gonna be able to have a spec that can be followed? So,
Absolutely. Nope. So how are we looking on our answers?
well, the answers, most of the most common vote is B. Got a few folks voted for C, and then a few folks who stuck in their own answer. We've got a 6%. We've got a 5 to 7%. So,
Okay.
I guess those would be others, and they put a what? So they gave us more specific. So,
Gotcha. Okay. Well, we'll get back to that in a second. Good. Thank you. So when we look at our components, typical range for your aggregate, 93 to 97% by weight. Your liquid, 3 to 7% by weight. So our 6, whoever answered 6 was right on the money. They know their DOT spec. Air voids, 2 to 4% by volume. So going back to our answers, our quiz a second. If you answered 1%, you're looking at a lean mix that's going to fall apart on you. If you're looking at a 10% mix, that's a pretty rich mix, and that's going to start, it's probably going to be squishing around on you. You're probably looking at some rutting. At 25%, you've got yourself one messy pond of asphalt. That's not going to be workable. Not going to set up on you. So the 3 to 7% again, that's where we're targeting, depending on the mix type for our liquid asphalt. But good answers, thank you. The mix design system that we use to mix those components up, come up with our asphalt pavement product, is a super pave mix design system. Been around since the late 90s. And one of the key components of that system is the use of a gyratory compactor. And we use that because it best duplicates field compaction efforts. In terms of your fine and coarse aggregates, you've got your sand component, you've got your stone component. The key here is you really want to stick with DOT approved materials. By sticking with DOT approved materials, you're going to make sure that you get aggregates that give you appropriate strength, give you appropriate durability in terms of freeze thaw resistance. Gives you, by sticking with approved materials, you're going to be getting the appropriate friction characteristics so that they're going to be resistant to polishing, and you're going to get general cleanliness, your aggregates that meet general cleanliness requirements. So all the things that you need to make that asphalt pavement work. In terms of your liquid asphalts, we use what is called the performance grading system for PG binders. This is also part of the super pave system. Been again around since the late 90s. And though that grading system is based on a variety of climatic, traffic, and area-specific considerations. A typical binder that we would look at under the PG grading, under that grading system is a PG 6428. And that 64 is a Celsius temperature, and that represents the highest temperature that pavement's expected to reach. And that's about 150 in terms of Fahrenheit. And then on the -28 side, that's the lowest temperature that pavement is expected to reach, and that's about a -70. And that's where, if you look at the 64, 150 Fahrenheit, your pavement's starting to melt. And on the -28 side, -70 Fahrenheit, that pavement's turned into a block of ice. So those are the temperature ranges that binder is expected to perform in. In terms of the binders used in New York State, originally we were using the binders that are shown on this slide. Typically, you would have seen a PG 64 -28 upstate and a PG 76 -22 downstate in high traffic conditions. But over the last 10 years, binder technologies have evolved, and binder grading technology or binder grading system is evolved with the technology. We now use what is called the MASCR system, stands for multiple stress creep recovery, MSCR. So we use MSCR grading in New York now, and we've added an alpha indicator to the grading system. You look at the key at the bottom of the table, And that key, that alpha indicator, that letters is an indicator of traffic, a traffic level. So S is standard, H is heavy, V is very heavy, and E is extreme. And applying that to what we see in New York, at least on the DOT side, because we use 100% modified liquid asphalt, upstate, you now see a typical grade is a PG 64V, very high traffic, -22. And downstate, you see a PG 64E, extremely high traffic, -22.
So John, that's 150 to -8.
-8?
-8, yeah, 22. -22C is -8 Fahrenheit.
I guess I can't, I read my calculator wrong.
It gets
I said
cold, but not that
-80.
cold. Remember they crossed over at -40, so.
Gotcha. Well, I'm still gonna call -8 a block of ice.
It is cold.
It is cold. In terms of, that's funny, good catch. Asphalt, in terms of our asphalt mix types themselves, you've got base, big stone, you've got binder, medium stone, and you've got top, smaller stone. In terms of mix types and their mix designations, we use the max stone size aggregate in millimeters to define the mix designation under the super pave system. So our bases are 37.5 millimeter. Our binders are either 25 or 19. And one thing to remember here is 25 millimeters equals an inch. Our tops used for overlays, 12.5 and 9.5. So that 12.5 is an inch and a half. Is a half an inch. The 9.5 is 3/8 of an inch. Then we've got our other mix types. You've got our 6.5 millimeter mix, which is our thin wearing course. That's a 1/4 of an inch. And then you've got the 3.2, which is T&L and shim. So applying that to our item designation descriptors, now you'll see for any of your DOT spec items, 404 is your asphalt pavement materials, replacing your warm mix asphalts, or essentially the same as your warm mix asphalt. Then you've got your period, and you've got the next two characters, and that's your mix designation in millimeters. So a base will be 404.37, a binder will be 404.25 or 19. Your top will be, top for overlay will be a 404.12 or 404.09. And then your thin wearing course will be 404.06, that 6.3 millimeter mix.
Hey,
The
John,
other designator.
got a question for you.
Yes, sir.
In the Q&A, it's a good question. Why are we using millimeters? For the,
Well,
size?
we are a U.S. customary state or country, yes, agreed, but the super pay system started in millimeters and then stayed in millimeters. Anything else to add, David?
That's it. That's it.
It's pretty straightforward. I asked the same question 100 times myself, but now I know the millimeters. In terms of the other designators, they just talk about compaction, friction, quality adjustments, and spec revision. So let's take another quiz. Again, put your answer in the Q&A. What's the minimum thickness for a 404.12 top course? And David, I'm going to let you tally them up and let me know what we got, please.
I'm doing the math in my head. Have to count. Get both hands.
You're way ahead of me then. We'd be in trouble if I was doing the math in my head. Just ask my DOT colleagues.
It's quite a range here. But everyone of us got at least one vote.
Excellent. Okay.
And it looks like the dominant answer is B, with C in second place and D in third. But it's
Okay.
pretty close. But looks like B and C are the top two.
Okay. Anybody that answered A and B, you're going to end up with a product that looks like what we're seeing in the middle of this slide. That 12.5 millimeter mix is a 1/2 inch top size stone. You can't put it down at a 1/2 inch or even an inch. Anybody that answered C, they know their DOT spec. That was the requirement up till recently. And then anybody that answered D really knows their DOT spec. Another bit that's in, talk about that real quick. Another big change that came out of EB 21047 was it updated the lift thicknesses to better match the 3 to 4 times max stone size guidance that's accepted internationally. Key change was to the 12.5 mix, the tops that are used for overlays. Previously, we always used 1.5 inch minimum thickness, but we were having problems with stone dragging. And so that was increased to 2 inches minimum. So your 12.5 goes down 2 inches minimum, your 9.5 can still go down at 1.5 inches. So another quick quiz. Looking at, moving on into equipment. What's the most important piece of equipment that we use on a paving project? Quick tally, if you would, David. And I'm going to jump ahead.
Hey, by the way, real quick, somebody had mentioned they saw DOT paving a 9.5 at 1 inch this summer.
Well, I'd like to see. I'd like to know where. I'd like to know where that is, and I'd like to see how long it lasts.
Yeah. In terms of your equipment, D and B are by far. D is the clear leader. I do have a couple of votes for others.
Gotcha. Well, I think I'd agree with the Ds, and I can see an argument for the Bs. But yeah, all equal. In terms of hauling equipment specifically, clean, smooth, tight metal beds, waterproof tarps, approved release agent. Big key here is you got to have a sufficient number of vehicles to keep that paver continuously fed. You don't want to be stopping, otherwise you're going to be introducing bumps or waves into that pavement, and definitely no fuel oil. In terms of your pavers, here's just a cutaway of a conventional Blawnox. You've got your hopper on the left, your drivetrain or your tractor in the middle, and then your screed on the right-hand side. In terms of rollers, three typical types. You've got your static drum, you've got your vibratory drum, and then you've got your pneumatic tire rollers. Your vibratory is our typical breakdown roller, and either the static or the pneumatic tire are used for finish rolling. In terms of asphalt overlays, one of the key overlooked and underappreciated activities we need to perform is applying tack coat. It's critical to getting a good paving product. You want a good a uniform V-shaped spray coming out of that spray bar. You want a nice, uniform spread over that surface to be paved. And because that tack is an emulsion, you're going to see it turn from brown to black, and that means you're ready for paving. But that's the glue that holds that mat to the existing surface. You want proper head of material. You want to see it about halfway up on the auger. If it's too high or too low, you're going to have problems with your mat thickness or waviness in the mat. In terms of rolling, you want to have a sufficient number of rollers to adequately compact that mat. And you really want to make sure that that mat is compacted well. That's the key. Getting density is the key to pavement performance. Another overlooked and underappreciated area that really needs more attention during our paving process are our longitudinal joints. You want to get an inch. You're targeting an inch of overlap from the new mat to the previously paved mat, half an inch either way. And we strongly encourage the use of joint adhesive. And then you can see in this picture, it's a good example. You don't see any tack coat and you don't see any joint adhesive. So this is this is a risky proposition. You put that tack and that joint adhesive down, you got a lot better chance at good performance. Let's switch gears a little bit, talk about weather. Another quick quiz. What are the seasonal limits upstate for our asphalt paving products?
Okay, John, while they put their answers in, got two questions for you.
Yep.
Go back so they can see the choices here.
Yep.
Hey,
Yeah, I got hung up.
For the compaction,
Yes, sir.
they want that, somebody asked, is that thickness for the compacted thickness or the paver thickness?
You're going to be laying it, you want that finished mat. So for your 9.5, you want that finished mat at 1.5 inches. And so the rule of thumb is 25% more on that 1.5 inches, essentially getting it up around 2 inches so that you get a appropriately compacted mat.
So it's always a compacted when we're talking thicknesses, because that's what we can measure later on anyway. So it's compacted thickness. Yep.
Great.
And then the other one, what about applying tack coat between the fresh binder and top course in a single paving operation?
It's not required, and some people do it and some people don't.
I would say it depends on how long you've got between. If it's just a few days, it's one thing, but if like a project where you've been a month or two, I would put tack.
Absolutely, and I apologize. If you've weathered it over, if you've wintered that surface, you've got to put a tack coat down.
Well, even if you've got a month or even a few
No,
weeks.
I don't disagree, but I mean, clearly you're going to be required if it's a wintered. But I'm with you. Once it's been there for more than a little bit of time, you got to put the tack down.
So we got votes for A, B, and C. Most of them appear to be B is the most common, but there's quite a few for A and C.
Yep. Well, anybody that put B knows their DOT spec. Anybody that put A thinks they're paving downstate, and anybody that put C and D, I like your thinking because you've narrowed your window, and those are the times that are going to give you the best chance of getting a good paving product. So good answers all around.
And by the way, if you're doing cold mix, I definitely would go Memorial Day, Labor Day.
Gotcha. And if I remember correctly, the other come back. Memorial Day to Labor Day, we're talking about any of our emulsion products.
Yep.
So chip seals. And then when it rains, anybody like to pave when it rains? Just raise your hand. I hope David doesn't see any hands, because when it rains, don't pave unless
No
it's
hands.
absolutely
No hands.
necessary. Good. Halt your production, keep your loads covered, got to keep that water away from that pavement or that material. You're going to place what's been produced. You got to get that out of the truck. You really want it to have any kind of hope in terms of compaction. You're going to slow your paving rate down, but you're going to be trying to roll as quickly as you possibly can. And you're going to be taking more passes. That's the only way when you've got moisture to try to get to the point where you're hitting your density requirements. But again, the bottom line is don't pave. In terms of QC, QA, quick quiz. Oh, come back. Get a little ahead of myself. When you're looking at both QC and QA, which party is responsible? Which party or parties are responsible for both those activities? Quick show of hands.
You're getting, guess what answer you think you're getting the most of?
I hope I get D.
You got D, yep.
Excellent. Good. Everybody's tuned in because it is the and. It's QC and QA. In terms of plant QC, QA, DOT approved plant, producer QC plant, certified technicians, and a variety of testing, including gradation, asphalt content, air voids, etc. Field QC, QA, it revolves around density. Density monitoring is going to be based on our mix series, but typically we're looking at roller passes on our local projects, which corresponds to our DOT 80 series mix. You're also going to be looking at mat temperatures, thickness, and surface. Last but not least, to wrap it all together, you've got to have a pre-pave meeting. You're bringing all the pieces together. You're getting the owner, the producer, the suppliers, everybody that's involved in the operation around the table. You're talking about all the aspects of the operation. You're particularly focusing in on your QC and QA, and you're also talking about your contingency plans. Something's always going to go wrong. You're always going to have some hiccups, and you need to be prepared. So while the goal is that everything's going to go right, the plan is to deal with everything that can go wrong. So wrapping it up, what's the correct treatment here? Well, the framework we use, right repair, right place, right time and right way. And in this case, I think all we're talking about is getting that snow plowed. Hopefully we're not going to see snow for a little while other than on the ski slopes. Bottom line, we focus on pavement maintenance. That's the best way to keep good roads in good shape. But eventually our pavements are going to wear out, going to require some rehab. We want to have a good full toolbox. You need a variety of tools, both in the maintenance and rehab side. On the rehab side, particular to our asphalt paving products, we're going to be looking at WMA only in 2023, no hot mix asphalt on DOT projects. And regardless of what treatment you're talking about, good practices are critical. Again, right treatment, place, time, and right way. So, and closing, as always, first question we need to ask and answer regarding any project we're taking on, how's the drainage? This is a picture that David has shared. He credits it to a gentleman, Jay Olson, and this is the key. Drainage is critical for roadway design. Ducts are an indicator of poor drainage. And if your proposed project site looks like this after it rains, you got to take care of the water and the ducts before you do anything else. With that, getting ready to close up. Here's our workshop schedule. You'll see we've got 7 different workshops, and our paving workshops we're gonna do an eastern and a western swing during April and May. Got some other training opportunities that are ongoing. We've got webinars. Check the website. Got a lot of them through the spring. And David does a weekly bumper banter, a Facebook Live session at 9 a.m. Covers a wide variety of topics. Real good resource. Again, spring workshops are open. Hope to see you there. With that, thank you. Hope this was informative. Appreciate everybody spending time today. Have a good set of holidays. Have a good winter, and hopefully we'll see you in the spring. David,
Or next
anything
week.
else?
Next week on the web.
I'm sorry.
Hope to see folks next week on the next webinar.
That's right. Next webinar is coming back.
Other direction.
Oh,
Other
I missed
direction.
it.
Went too far.
Yeah, there we
There
go.
you go.
So, streets and roads legal issues, big topic. You got a lot of interest in that this year. Department duties, that's a great webinar. And pavement management on the 10th, that's another great webinar that Jeff Scott and David do, and it really talks about it does a nice job talking about the Cornell pavement management tool. Anything else, David?
That's all. Everybody have yourself a great day. Thanks, John. Thanks,
Thank you,
everybody.
David. Thanks, everybody.
Take care. Bye-bye.
Take care. Bye-bye.